National Electrical Code Article 300.7b addresses the requirements for service conductors entering a building, specifically concerning protection against physical damage and fire resistance. It states that when service conductors enter a building from a service lateral, they must be encased in at least 6 inches of concrete for a distance of not less than 10 feet from the point of entrance. This requirement aims to provide a robust protective barrier for the service conductors. The purpose is twofold: firstly, to shield the conductors from potential physical damage that could occur during or after construction, and secondly, to act as a fire-resistant barrier, preventing the spread of fire along the service conductors into the building. The code recognizes that achieving the full 10-foot concrete encasement within the building might not always be feasible. In such cases, the code provides an alternative solution: the service conductors shall be installed in a raceway. The type of raceway is not specifically defined in this section, but generally, a rigid metal conduit or intermediate metal conduit would be appropriate choices as they provide substantial physical protection. Now let's examine the exception to the concrete encasement rule, which pertains to service conductors installed in a chase. A chase, in this context, refers to an enclosed vertical or horizontal space specifically designed to house and conceal electrical or other building services. Article 300.7b acknowledges that a properly constructed chase can provide an equivalent level of protection to concrete encasement. To qualify for this exception, the chase must meet certain criteria. Firstly, the chase must be constructed of non-combustible material, meaning it should not contribute to the spread of fire. Acceptable materials for chase construction would include concrete, brick, or metal. Secondly, the chase must have a fire resistance rating of at least 1 IR. This means that the chase assembly, including its walls, floor, and any access openings, must be capable of withstanding fire exposure for a minimum of 1 IR without structural failure or allowing the passage of flames or excessive heat. Therefore, if the service conductors are installed within a chase that meets both the non-combustible material and the 1 IR fire resistance rating requirements of Article 300.7b, then the concrete encasement requirement is waived. Considering a scenario where the switchgear is located on the second floor of a building and the service conductors run inside a chase from the point of entry to the switchgear. If the chase is constructed of non-combustible materials such as concrete or masonry and has a fire resistance rating of at least 1 IR, then the service conductors within the chase do not need to be encased in concrete, even if the run is greater than 10 feet before reaching the first disconnecting means. It's crucial to properly document the fire resistance rating of the chase. This often involves providing documentation from the manufacturer of the chase materials or obtaining a fire resistance test report from a qualified testing laboratory. The local authority having jurisdiction, also known as the AHJ, has the final say in determining whether a particular installation complies with the NEC. It is always prudent to consult with the AHJ during the design phase to ensure that the proposed installation meets their requirements and interpretations of the code. In summary, the NEC requires concrete encasement for service conductors entering a building to provide physical protection and fire resistance. However, an exception exists when the conductors are installed in a chase constructed of non-combustible material with a fire resistance rating of at least 1 IR. Understanding these requirements and exceptions is crucial for ensuring a safe and code-compliant electrical installation. The code intends to mitigate potential hazards associated with service conductors entering a building. The concrete encasement acts as a physical barrier against accidental damage from digging, impact, or other external forces that could compromise the integrity of the conductors. It also provides a measure of fire protection, preventing flames from spreading along the conductors into the building in the event of an external fire. In situations where concrete encasement is impractical or impossible, the code permits the use of a raceway as an alternative. A raceway provides a similar level of physical protection and can also contribute to fire resistance, depending on the type of raceway used. The exception for chases recognizes that a properly designed and constructed chase can offer an equivalent level of protection to concrete encasement or a raceway. The key is to ensure that the chase is built of non-combustible materials and has a sufficient fire resistance rating to contain a fire for a specified period of time, typically 1 IR. When evaluating whether a chase meets the requirements of Article 300.7b, it's important to consider all aspects of the chase construction, including the walls, floor, ceiling, and any access openings. The materials used for these components must be non-combustible, and the entire assembly must be capable of withstanding fire exposure for the required duration. Access openings, such as doors or panels, must be equipped with fire-rated hardware to maintain the integrity of the fire resistance rating. In addition to the construction materials and fire resistance rating, it's also important to consider the location and accessibility of the chase. The chase should be located in an area where it is not subject to physical damage or abuse. It should also be readily accessible for inspection and maintenance. Proper labeling of the chase is also important to identify it as containing service conductors and to provide information about the fire resistance rating. The requirements of Article 300.7b are intended to provide a minimum level of protection for service conductors entering a building. In some cases, it may be necessary to provide additional protection, depending on the specific circumstances of the installation. For example, if the service conductors are exposed to a high risk of physical damage, it may be necessary to use a heavier-duty raceway or to provide additional physical barriers. Similarly, if the building is located in an area with a high risk of fire, it may be necessary to increase the fire resistance rating of the chase. It is essential to consult with a qualified electrical engineer or contractor to determine the appropriate level of protection for service conductors in a particular installation. They can assess the specific risks and hazards and recommend the necessary measures to ensure a safe and code-compliant installation. It's also important to stay up to date on the latest edition of the NEC and any local amendments or interpretations. The NEC is revised every 3 years, and changes are often made to address new technologies, emerging safety concerns, and evolving industry practices. By staying informed about the latest code requirements, electrical professionals can ensure that their installations meet the highest standards of safety and performance. Remember that the ultimate responsibility for ensuring compliance with the NEC rests with the electrical contractor and the building owner. They should work together to ensure that the installation is designed, installed, and inspected in accordance with all applicable codes and regulations. In the specific scenario mentioned, where the switchgear is located on the second floor and the service conductors run inside a chase, the key question is whether the chase meets the requirements of Article 300.7b. If the chase is constructed of non-combustible materials and has a fire resistance rating of at least 1 IR, then the concrete encasement requirement is waived. However, it's important to verify these conditions with the local authority having jurisdiction before proceeding with the installation. The AHA has the final say in determining whether a particular installation complies with the NEC, and their interpretation may vary depending on local conditions and practices. To avoid any potential issues or delays, it's always best to consult with the AHA early in the design process and to obtain their approval before starting construction. This will help to ensure that the installation meets all applicable code requirements and that it will be approved upon final inspection. In addition to the NEC requirements, it's also important to consider any applicable state or local codes and regulations. These codes may have additional requirements or restrictions that apply to electrical installations, and it's essential to comply with all applicable codes to ensure a safe and legal installation. The NEC provides a comprehensive set of rules and guidelines for electrical installations, but it's not a substitute for sound engineering judgment and professional expertise. Electrical installations can be complex and potentially hazardous, and it's essential to have the work performed by qualified and experienced professionals. By following the NEC, consulting with the AHA, and working with qualified professionals, you can ensure a safe and code-compliant electrical installation that will provide reliable service for years to come. It's also important to remember that electrical safety is an ongoing responsibility. Regular inspections and maintenance are essential to ensure that the electrical system continues to operate safely and efficiently. Any signs of damage, wear, or malfunction should be addressed promptly to prevent potential hazards. By taking these precautions, you can help to protect yourself, your family, and your property from the dangers of electricity. The National Electrical Code is a living document that is constantly evolving to address new technologies, emerging safety concerns, and changing industry practices. Staying up to date on the latest edition of the NEC and any local amendments or interpretations is essential for electrical professionals to ensure that their installations meet the highest standards of safety and performance. The NEC is not intended to be a design manual, but rather a set of minimum requirements for electrical installations. Electrical engineers and contractors should use their professional judgment and expertise to design and install systems that meet the specific needs of the application while also complying with all applicable codes and regulations. The NEC covers a wide range of topics related to electrical installations, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes specific requirements for different types of occupancies such as residential, commercial, and industrial buildings. Understanding the NEC and how it applies to different situations is essential for electrical professionals to ensure that their installations are safe, reliable, and code compliant. The NEC is not the only source of information on electrical safety. Other organizations, such as the National Fire Protection Association and the Institute of Electrical and Electronics Engineers, also publish standards and guidelines related to electrical safety. It's important to be familiar with these other sources and to use them in conjunction with the NEC to ensure a comprehensive approach to electrical safety. Electrical safety is a shared responsibility. Everyone, from homeowners to electrical professionals, has a role to play in ensuring that electrical systems are safe and properly maintained. By following the NEC, consulting with qualified professionals, and taking precautions to prevent electrical hazards, we can all help to create a safer environment for ourselves and others.